Right, here we're looking at parallel circuit resistors. So with parallel resistors, we have to add them up, but there's a formula to use. And this will reduce these two resistors to one resistor. So our formula to use is 1 over RT is equal to 1 over R1 plus 1 over R2. All we have to do is substitute into the formula. And substituting, use your calculator, use the fraction, and we are going to get an answer. So remember, our method is formula, substitution, and unit for electrical. And we are going to get 1 over 20. 1 over 60 plus 1 over 30 is 1 over 20 on the calculator. Please note that this is not the final answer because that is 1 over RT. For me to get the answer, I must take this answer here, 1 over 20, and press x to the minus 1 on a Casio calculator. This will flip the number and make it 20 over 1, which is in effect 20. So RT is equal to 20 ohms. So we are saying you could redraw this parallel circuit and now say that in the center is now 20 ohm resistor. So let's do a combination circuit. So combination circuits, we're adding another resistor, which is 20 ohms in front of the same parallel branch. So we are saying that in effect this was 20 ohms worked out in the previous example, and now we have another 20 ohm. Just looking at it, I can easily see that this and this is now connected in series. So we have 20 ohms plus 20 ohms, which would give us 40 ohms. Okay, so substituting into the formula, substitution, unit. So the combined effect of all of this is 40 ohms, right? So let's say we add power to this and we give it 12 volts. So 12 volts is the force, and when we place a force, we're going to get a current. So that current will be I total. So in this question, we want to now calculate what is the current flowing in this circuit. So very simple, we already know that the opposition to the current flow is 40 ohms. So I total is equal to V over R. Don't forget that the force is the voltage, which is 12 volts, right? So the 12 volts divided by the 40. But something to notice here with current is that it will split into these two branches. Will the current be the same in these branches, I1 and I2? Since the ohms is different, the resistance is different. So remember, ohms resistance is the opposition to current flow. So that means if it's opposing, there's a big rock in the way of the river, this means less water is going to flow. So we can clearly see I2 will be larger because there's less resistance here. I1 will be a smaller value because there is more resistance on the top. Right, so substituting, we will get 0.3 amps. Okay, that's I total. Do note that I1 and I2 is not equal to 0.3 amps. However, it is a combination, it is a splitting up of 0.3. What will come out on the right hand side? So on the right hand side, it will return back to 0.3. At this point, it will split into two values and return back to 0.3. Okay, you with me? Right, so that is I total. So calculating I1 and I2. So we have a parallel circuit. So do note that the voltage across these two will be the same. How do we know this? For parallel circuits, voltage is the same across all the branches, but the currents are different, right? We will also have a voltage on the left hand side. So do note, because the overall resistance is 20 on the right hand side here, and the left hand side is also 20, I can easily conclude that this 12 volts will be split into 6 volts and 6 volts for this parallel connection. Remember that series circuits are voltage splitters. Don't look at these two, just assume that there's 120 ohms here for now, and that means half of the voltage will go there and half on the right. So it's going to be 6 volts and 6 volts, right? So this means this voltage is 6 volts and this voltage is 6 volts. So we can calculate the current by saying V over R. Calculate the current by V over R. Okay. So remember that V1 is across here, and we can calculate that by saying V is equal to I times R. So we know what the current is flowing through this resistor, and we have the value for the resistor. So I times R will give me 6 volts. So this proves that I'm right in saying that there's 6 volts here and 6 volts there, because by calculation I do get 6 volts on that voltmeter. On the right hand side we also have 6 volts. Let's prove it. So we're going to say 6 volts divided by the 60. So 6 volts divided by 60 ohms, we're going to get a current of 0,1. 6 volts divided by 30 ohms, we're going to get a current of 0,2. Add those two numbers up, 0,1 and 0,2. Do note you get I total, which is 0,3. That's going to flow right through the circuit until it gets to the branch, splits and returns to 0,3 amps. So 0,1 and 0,2 is at these points. Add them up, it becomes 0,3, proving that the left hand side is equal to the right hand side. So one good thing you can find with these calculations, you will know if you are right or wrong in your calculation. Let's look at another circuit in parallel. So the 40 ohm and the 10 ohm here are in parallel. Do pause the video and attempt this and see if you can do it. So the total circuit resistance here will be, right, 1 over RT is equal to 1 over R1 plus 1 over R2. Substituting into the formula, we get 0,125. Right? But that 0,125, okay, so this 0,125 is 1 over 8. Okay? But this is 1 over RT is equal to this 0,125. So please just include a 1 on top of RT. You need to use your calculator, x to the minus 1. This will give you RT is equal to 8. Okay, we can now find the total current from the battery very simply by saying the voltage applied over the resistance total. Okay, so 24 divided by 8 will give us 3. So the current flowing in the circuit is 3 volts. Okay, don't forget, for us to calculate 1 over RT equals 1 over 8, all we do, we use x to the minus 1 on our calculator.